All right. You now have your star formation region image. You have LRGB, which focuses on the stars. You have your narrowband layers, which is hot gas that's been heated by the stars. You have infrared layers, which includes warm dust that was heated by the stars, and sometimes also dust-hidden stars, depending upon which bands, which wavelengths you incorporated. So you have this awesome image, and this one's of the eagle, but you each did your own, and it may have some elements in common with this. In this one here, you see all sorts of bumps and lumps. You see pillars and columns and spires and globules, and we'll be talking about those kinds of features in this video. It will help you to tell the physical story of what's going on here. Though some of your regions were very different, and it focuses more on the dust, both line of sight dust and reflection nebulae, which are due to dust. We'll deal with those in the next video. So this video, let's focus on regions like this. So again, here are the hot stars. They're driving all of this. They're heating up the gas, ionizing the gas, and giving us our H alpha, our S2, and our O3 in this inner region here. That hot gas, it's expanding, it's pushing against the cloud, and the cloud is not uniform. It's bumpy and lumpy, and some regions are denser than others. And if you have a dense region like right here, it's easier for the hot gas to just go around it. So they act as shields, protecting all the gas behind it. Notice how these pillars are pointed towards the hot stars that the gas is moving away from. You have a shield and it protects stuff along that flow. So you have pillars. Actually, these are rather famous pillars. This is the Eagle Nebula, but these pillars are called the Pillars of Creation. From this early Hubble photograph. Here you're just zooming in on this portion right here. And this is a narrowband image. It's O3 in blue, H alpha in green, and S2 in red. So this is a Hubble palette. So the colors are a little bit different. In fact, they don't even have an LRGB for the stars. That's why the stars are so weird. Those are just whatever the star is emitting in those narrow bands. So often with Hubble images, the stars will look weird, but here you have the Hubble palette. And again, these are dense regions, and the gas, instead of pushing through them, works around them, and they act as temporary shields. This is a more recent Hubble image. While the shuttles were flying, it was a serviced spacecraft. This spacecraft has been up there forever, since 1990, I think it was. And for a long part of its history, it would get periodic visits with new equipment, better equipment. And so you go from this to later on in its mission, it can do this. And this is also a Hubble palette image of the pillars. But they're more than just pillars. There are these terms pillars and columns and spires. I'm not going to make a big deal of the difference. Here, let me zoom out here. This is someone else's photo, but these things are pillars. Columns, as I understand it, they're a little bit broader and more squat. This might qualify as a column. This over here is a spire. It's very narrow. So you had this dense region and protected all this back here as the gas expanded around it. Now, the thing is, these are temporary structures. The gas expands around it, but then it squeezes it from the sides. This is maybe not the most pleasant analogy, but what happens is the same thing that happens in a nuclear explosion. In a nuclear blast, the blast wave moves very fast. Like if it's expanding and running into buildings, it doesn't topple over the buildings because it's moving faster than the buildings can topple. So the gas expands around the buildings and squeezes them from all sides. In a nuclear explosion, the buildings don't topple, they get imploded from all sides. that's kind of what's going on here. This gas is expanding faster than the local sound speed, but that just means faster than these pillars can respond. They hold, but then they get squeezed from the sides. And that squeezing will fragment the gas, and the fragments will fragment, and so forth and so on, until you have star-massed fragments, and they form stars. And those stars will continue to drive the nebula bigger and bigger. It's a process. It's a cycle. It's the cycle of life out in the universe. Sometimes you can see the stars being formed. Here's another famous Hubble picture. This is the Carina Nebula. And if you look here at the tops of the pillars, you see these jets flowing out in two directions. Here as well, you see jets. And these are stars being formed. What's going on is once you fragment down to a star mass blob of gas, it collapses into a disk. And these red lines are magnetic field lines. Let me just turn this sideways, and you see the magnetic field lines running through. As this disk rotates, and it rotates differentially, faster in the middle, slower in the outskirts, these magnetic fields get wound up. And some stuff can flow out along them. Not everything ends up forming the new solar system. You get these outflows. We call these Herbig-Haro objects. This is an example of one. You don't see the middle here because it's very dusty, but you see light above and below, and you see the outflows, and that's what we're seeing here. So these pillars, they get squeezed and stars form, and sometimes you see stars forming in your image. And as part of this exercise, I want you to look at not just your image, but I want you to pull up Hubble and Webb imagery and compare your image to that. Okay, this is star formation. And then you have the globules. So as this process continues, you can see how it's eating away at the pillars underneath. And eventually, they'll become separate. And it'll eat its way all the way back up to that dense starting point. And it's there by itself, getting squeezed from all directions. And we call those globules, or Bach globules. Here you see one, here you see one. Here's one from a different region. All the red is H alpha bomber emission mostly, but see the Bach globules here. They're the last bits that will form stars. Okay, so that's it for this video. The next video, we'll talk about a very different looking kind of star forming region.